Okay. POCO relationships. Remember, POCO stood for plain old CLR objects. Again, emphasizing that when we create our properties inside these model classes, we don't really get into doing much in the way of adding code to setters or getters or anything like that, except for, well, the getters sometimes, especially for read-only ones that don't have a setter. But the properties that get persisted to the database, we just have simple properties there. Okay. Families come in all shapes and sizes, and so do database models, right? So we're going to start off with some basic assumptions. Unless stated otherwise, our entity models have an integer identity primary key named ID. I've mentioned already, as naming conventions, you're free to name this primary key either the entity name with ID at the end or just the letters ID, right? And I strongly suggest you get in the habit of just using ID. There are numerous reasons, but one simple one that actually came up in conversation with a student the other day is it helps us easily see when I go to create a foreign key, if there's a one-to-many relationship, for example, in another entity, then I can use the entity name ID. For example, we had our mask type, right, with a primary key of ID, and then we had a mask type ID as a foreign key in the mask entity. And that made it very easy to see that mask type ID was the foreign key. But there's other reasons as well. I've mentioned them. Oh, by the way, this is in Seattle looking out the window. I was on a training course with Microsoft. I took that picture. Okay. So the most common database relationship, one-to-many, right? Now, I've got a note here, parent required. In other words, the foreign key on the child side is definitely a required value, right? We can't have an orphan child without a parent, okay? So lots of examples I could choose from. I'm going here with province and city, right? A province has got many cities. A city is inside one province, right? So how do we establish when we're creating model classes to represent this kind of a one-to-many relationship? How would we actually get the primary foreign keys in place? Well, what we do is in the child, okay, the child side of the parent-child relationship, what we do is we add, most importantly, an object of the parent type, right? So that's where I have my public province, right? And it should always be nullable when you create this, because we don't always want to actually populate, so to speak, this city instance of the city class with a hard and fast province object, right? So we always make that nullable. Now, I mentioned the other day when we were having our first demonstration, along with that, if we had that alone, believe it or not, that is enough for Entity Framework to recognize, aha, this is a one-to-many relationship and set up the database accordingly, right? Just having that province object there inside of city. But what the system would do is it would generate its own, whatever the data type of province is. Now, we've said we're going to go on the assumption that's a integer identity named ID, right? So what it would do is it would create an integer to hold the foreign key value, the integer value, inside of city as well. But we wouldn't know the name of it. We wouldn't have access to it inside the class, and that would just be an inconvenience for us. So it's going to be there anyway, so why shouldn't we make sure we have access to it, right? So that's why we would always also add public int because we're always working with integer identity primary keys. So we'll have a foreign key, public int, province ID, right? And that naming convention works very well with Entity Framework Core as well. So that is the ideal arrangement to put that foreign key in. Now remember, this is a parent required, right? In other words, that integer, the foreign key integer for province ID, notice there's no question mark there. It is an absolutely required integer. We must provide a value for that. We don't have to populate the province object necessarily, but we must have that integer there. Almost done. But the other thing we normally add to any one-to-many relationship is in the parent. We will add a collection of the child objects. Not absolutely necessary, and usually what we'll do is we'll make sure that it could be, null or an empty collection. That's not a problem. The collections are nullable by default, right? We'll often initialize it though, so it isn't null, just to avoid null reference issues before we go on. You'll see that in our code samples coming up soon, right? But the point of having this collection in the parent, it just makes our programming much, much easier because we can use a dot include. So I could do a query where I ask for all the provinces, for example, but dot include the cities, right? And that is essentially the same functionally as having a join between province and city without having to actually write a join clause. Okay, right? So it is optional, but it allows us to do a dot include. And there's very rarely I've ever seen any reason not to have it there, right? So I encourage you to pretty much always go ahead and put the I collection in place. All right. Okay. Now, if the parent was going to be optional, so here we have a similar situation. It's a one-to-many relationship. Department has many employees, okay? An employee can only be in one department, but we might have like a floater employee that's not assigned to any one department, right? So this would allow that. And notice the only real change is that inside of the employee entity or employee model, we have public int question mark department ID, right? So that is a nullable int, and that's all it takes to make the parent optional, right? So that's a real-world situation that does come up once in a while. Yeah, it's true. Most of our one-to-many relationships are of the first variety where the foreign key is required, but here we can make it optional, and that allows us to have an employee that isn't actually assigned to any one department, right? Okay. Ooh, look at that animation. Ooh, I worked hard on that. I hope you appreciate that. All right. So there are a few special cases to consider before we go on. Integer primary key that is not generated by the database, and sometimes we might have a string primary and foreign key, right? So yeah, we'll just have a quick discussion about these. Are much more rare, but we might as well talk about them now, okay? So integer primary key, typically used when we set the value of the primary key and use it to represent something related to the entity. In other words, we don't want the system to generate it. Maybe it's a value that we want to be able to assign, right? Rather than leaving it up to the database to just come up with the next available number, right? So we still mark it with this annotation of key, okay? And that clarifies that it is the primary key, right? But we also are going to say database generated, the option is none. So the database does not try to create it, right, for us. And that allows us to just set it ourselves in code. So that's a workaround for that. If you ever come up into the situation where, no, an identity is not what I want, I need to be able to assign my own value for this integer primary key. Okay. All right. What about using a string? Well, there's good reasons why integer identities are used so often. They're very efficient. The consistency is there, right? But there's some circumstances where a string does make sense, right? Where a unique identifier as a string, okay, is the better candidate. I've got a few criteria here. As long as this primary key value is going to be reasonably short, like not a great big huge long string, because that's going to be very inefficient, right? If it's something that is naturally unique in the real world, like, because remember, our models do represent data coming from the real world, okay? And if it's most of all meaningful, in other words, if the primary key value, this nice, reasonably short, unique piece of string information or text information is meaningful, then that's another really good reason why we might want to actually use a string instead of an automatically generated integer identity, okay? Just have a quick example here. Think of regions in a country. Now we're going to talk Canada, so of course we have provinces and territories. We're all aware that all the provinces and territories in the country have these unique two-letter codes, right, that define them. ON for Ontario, BC for British Columbia, and so on, okay? So if we make that the primary key, and then the foreign key, okay, in our province and city is the actual region code, then we have a fully functional primary foreign key relationship, parent-child, one-to-many, away you go, right? And the other nice thing about it, it would allow a summary property in the city, in other words, a property that we're preparing specifically to show on the screen, where we could concatenate together the name and the region code. They're both sitting right there inside of the city model, okay, the city entity. So we could put it together. So it could say Welland, ON for Ontario, right? And we don't even have to have a join or involve in any way, shape, or form, right? The other parent entity, right? All the information is self-contained inside the city object itself, right? So that's an example of where a string would actually work very well. So how do we get that set up inside our actual model classes, if that's something we decide we want to do? Okay, well, here we have our province city example again, but this time using our 2-character string, right? So inside the parent there, you see we have our public string ID, right? Now it's not nullable. Of course, it shouldn't be. Primary key should never be nullable, right? So notice it's annotated with key, annotated with database generated option none. And we can even specify the string length as 2 because all province codes are only 2 characters, right? Okay, on the child side, inside the city, right, we still have our province object here as marked as the as a question mark, so a nullable province object, right? But our province ID this time is, of course, a string, okay? And those annotations there, the display name province, required, you must select a province, string length 2, those are all for our convenience, right? But it's actually the one on top of the province object. This is what actually enforces that province ID is used as the foreign key, right? Property of the city to relate back to the primary key in the province entity. We say the foreign key of province ID relates to the province object itself, right? Or sorry, another way to put it, oh, I spelled province wrong. Oh, sorry. Or did I? I'm dyslexic. Forgive me. All right. There you go. You get the idea, right? So that's how we can set up a string. And the name does not need to be ID in this case, really, because we are fully annotating it as the key and everything else. But, you know, for consistency, I could, by all means, simply stick with using ID. And that's probably what I would do personally. Okay. All right. We're going to talk a little bit more. Let's talk about many-to-many, because we'll soon be introducing many-to-many relationships as well, okay? All right, so with a many-to-many relationship, we have an intersection or associative entity. Now, this is something you talked about right back when you were first learning relationships with SQL itself, right? The fact that you needed some table in the middle to support a many-to-many relationship. So it's very similar with our entity models, right? So a student could be in many courses. A course has many students, right? So we'll have a associative table. In this case, I'm calling it enrollment, okay? Associative or intersection table, you might have heard either term. I try to always say both because some students have heard one or the other, right? Now, this is an example where we're talking about no payload. What does that actually mean? Well, no payload means that there's nothing else stored in this intersection or associative table other than the foreign keys, right? So in a simple case like that, this is how we would arrange it, okay? Now, of course, obviously there's going to be other properties here I'm not showing. I'm just focused on the ones to support the relationship, okay? So what do we see inside enrollment? Well, 2, count them, 2 foreign keys. Now remember, we've just talked about one-to-many foreign keys. So this is the central entity that supports 2 one-to-many relationships. Student has many enrollments, enrollment for 1 student, course has many enrollments, etc. Oh, by the way, the name enrollment, kind of a side point, it makes sense, right? It works in the language of the system. I've said before, and you were probably taught back when you were first learning about many-to-many relationships with SQL, if you don't have a good sort of meaningful name to represent these intersection tables or associative tables, then often what we'll do is we'll just concatenate the names together. So it could be student course would have been another possible name for what we're calling the enrollment entity here. Okay, getting back on track to looking at the foreign keys. So not surprisingly, to relate back to the parent course, we have the nullable course object and the public int course ID, right? To relate back to the student entity, we have our nullable student object and the int student ID. Okay, there we go. And that gives us our arrangement we need. Now, mind you, every entity must have a primary key. So what is going to be the primary key of enrollment, right? Well, what we're going to do is we're going to do a composite. You remember learning composite keys with SQL. A composite key is when you combine properties together or fields together, right, to make a unique combination. So here, the combination of student ID and course ID would be made unique, right? Okay, as I note here, composite key created in the Fluent API. Now, I think that you might be able to do it actually with annotations now, but I'm going to continue showing you the way that is tried and true. We'll just use the Fluent API. We have to do other things in there anyway, so that's where we'll actually write the code to specify the primary key here of our enrollment. And by the way, we will never create a controller in a case like this for enrollment, right? We don't need to have a controller in views for that. What we'll do is we will manage it from the parent entities, right? Most likely on student, we might have showing all the courses, and we can just check off this course, that course, the third course, and a few check boxes, or maybe two multi-select list boxes or something where you move things back and forth, right? Something like that in the UI, right? It could be done on student, it could be done on the course. Most likely the student, though, to be honest with you, because usually there's a lot more students in our courses, right? So check boxes or something like that on the UI. So again, the point is we don't actually build something as a user interface for the enrollment itself. Okay, so many-to-many with no payload, right? So we add the DB set for the intersection table as well as, of course, the two parent tables, right? And then in our Fluent API, the on model creating, we had a look at that the other day. That's how we created our restriction on cascade delete in our one-to-many relationship, right? We would just go in this. We'd use the model builder, go to the enrollment entity, and we say has key, right? Using a lambda expression here, making a new combination of the student ID and course ID. And that in our Fluent API would define the primary key of the enrollment entity as being that composite of the two values. Okay, and as I note here, we often use things like checkboxes or list boxes in the UI if there's no payload. There's nothing to describe about this relationship except that it exists. The student is in this course, right? And that's it, away you go. Okay, the other situation with a many-to-many is we do have what we often refer to as a loaded intersection. There's additional information that we're going to store here inside of this associative or intersection entity. So think department and office, okay? A many-to-many relationship supported in this case, instead of department office, we'll say employee, right? So an employee might be in a given department, also might be in a given office, and away we go. In this case, though, the employee is obviously going to have many other properties to go along, right, besides the two foreign keys that support this many-to-many relationship, right? First names and last names, employee numbers, and date hired, and so on and so forth. So that's why I have that ... there, right? So the main difference you're going to see here is that in a case like this, where there's going to be other properties in addition to simply supporting having the two foreign keys to support the many-to-many, what we'll do is we will create a separate primary key, again, following our normal approach here, an integer identity, simply named ID. That's going to be the primary key of the employee, right? For the foreign keys, well, we do set them up pretty much the same way. Notice they're both required, right? We have a nullable office object with office ID integer, nullable department object with a required department ID integer, right? The main difference there is that the primary key is not that composite. What is it? Well, it's its own unique integer identity, and it'll have its own controller and views going forward, right? So we'll definitely make an employee controller where we can create, update, and delete employees, etc., right? So, all right. How do we want to cascade delete? Oh, sorry. I didn't mean to go this far, but that's okay. Yeah, we looked at this example. Want cascade delete on one side of the many-to-many? Well, that's where we can just put the same kind of delete behavior restrict, okay? So in this case, where we had enrollments in courses, right? If we don't want to be able to delete a course, if there are any students enrolled, then this would be what we would put in the Fluent API. All right, I'm going to leave the discussion of the PowerPoints there at this point. All right, any questions so far? Gosh, we're almost out of time. Yeah, so I'm going to stop recording.